Okay, thank you for joining this live stream. In this live stream, we're going to be solving MTH 122 exam questions. And you know how it is with this now our first exam review, we've done multiple exam reviews. So just like the other ones, we'll be starting off from question 1 to question 35. Before we begin, I just want to just say that for the people that are using this to study, right? You just need to know that this camera, let me share the video. Yeah, the old is working. So you just need to know that these exams, right? They are not. They're like I feel like how they do this. I'm not 100% sure. I'm not 100% sure. So don't take it like okay, it is you heard it from this YouTube guy. No, I'm not 100% sure. But I've written these exams and I believe how the lecturers reason is like they just have like a set of questions, right? Which they can go back to just restructure the question, maybe change one thing or the other, and they've gotten a new set of 35 questions. It's like jam. You just finish writing jam. Most of you just finish writing, not just finish, but like most of you wrote jam before you enter this university. Because this university does not use pen, they use purely jam. So I feel like the same way jam is that even if jam they don't repeat questions, you use past questions to study. You've seen that over the past questions, they do repeat something. Maybe you can see one or two questions that repeat after like in the whole maybe from 2000 to 2025. Maybe only one, two, three questions repeated themselves, right? Good. But you agree with me that even if only one or two questions repeat, more than 50% of that whole exam, or in fact, I can even say more than 75% of the exam, we are from past question. That is the chess making sound. That is like maybe ask you two plus two. The next they can ask you three plus three. I don't know if you get what I mean. You just change the number. That is the same way I can tell you, I can beat my heart and tell you that this exam will be. If you don't, I'm not saying only last year question. I'm not saying only last year question and last 2 year question. No, I'm saying go back last year question, maybe 5 years back. Go that year, in that last year, the next last year, the next last year, maybe 5 years back. I'm telling you, you can even see the whole 35 questions inside that place. And if you're the type of person that you can cram the whole exam and now go enter the exam, whenever you see this type of question, you know, okay, this is the type of answer you're supposed to get. Then you are doing yourself. You may end up changing one number. Go and check my MTH 123 exam video. You will see that I've, I've already cleaned the board. But the way let me just check, let me just confirm. Let me tell you the exact number of questions that the left changed one thing, just one number, and it made the whole exam, they made that whole question wrong. Like you made the whole options wrong. That means the answer is supposed to be none of the above. Let me just confirm. Let me tell you the exact number. Just in case you don't hear it, you can skip to later on the video. I'll still solve the question, but like before I start solving, I used to always just like give some introduction to the video. But let me just this 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 good questions. That is 9 out of 35. So you can just say 10 out of 35. That is like one third of the questions that came up from past questions. The lecturer changed one number. That number will now make that whole question not exactly the same as last year question. That is, let us say the number was 1.2 and the answer was to be 2.4. They will now change the number to 1.1. This last year old. Then this is the new year, this year. They will now change that number to 1.1. So now the answer is supposed to be 2.2 because there's no 2.3 inside the option. The correct answer is supposed to be none of the above. There will always be none of the above in your options. None of the above. None of the above. Right? Are you even showing on the screen? Yeah, showing on. Let me change my card. So the answer is going to be none of the above, right? But because of you now, you have not you, because you are smart type. Because of those type of people are going to go and cram that is just cram, not that they've learned how to solve. You just cram the question, cram the answer. Once you see something that has to do with blah 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 1.2. In this year, you see blah 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 1.1. But because of the same word for word, the same blah 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 blah, they will now say, okay, the answer that they got last year was 2.4. So whenever they go to the option and they see 2.4, they'll pick it. Knowing that this year they changed it from 1.2 to 1.1 and the answer was changed to 2.2. Let me check, let me bring this question. Question 5. I believe this was one of them. Question 5. Let me read the question. Find the unit normal vector to the surface x to the power of 3y plus 4x z to the power of 2 plus xy squared z plus 2 equals 0 at the point 1 and 1. This question came out last year. That is last 2 years. That is the year before this paper came out. Like the year before this exact question paper came out. That is 20, this one I'm using is 2025 2026. So 2024 2025. This exact same word for word came out, but the number there was 1, 3, 2. Then they now give you the option. But this year they changed that 2 to 1. So it's now 1, 3, 1. That means there's no answer in the options. There is correct answer is not supposed to be not inside the option because they changed one of the numbers. So now what is the correct answer that you're supposed to pick? None of the above. There's always going to be none of the above here. Good. So don't just go and say, okay, since I said the read past question, you now go and only cram the past question and the answer. No. Read past question and use it to learn how to solve. I don't know if you did jam now, but that's the same way you study for a jam. That's the same way you expect this question to be. Anyways, let's just begin. Let's begin. So we'll just start from the beginning. Begin the video. This is 7 minutes. Okay, I think I'll try to my best to tell you inside the description of the video that in case you don't hear discussion, just keep to 7 minutes later and you can start learning. I'm in my uncle's house, so thank you, uncle, for allowing me to use your board and your light and everything. So we'll start from question 1. Question 1 says, which of the following relations is a function from A to B? We have option A. Let me just write it down. I'll teach you people how to, because I've done this multiple times in the other test reviews, but this question came out in test. But I'll just teach you people inside this video on how to answer the question. We have question 1. Which of the following relations is a function from A to B? Option A. We have 1, 0, 1, -1, -1, 2, 3, 4, 10. Where A is equal to 1, 2, 4, and B is equal to 0, -1, 3, 1, 0. Sorry, 3, 1, 3, 10. Okay? I have option B. Option B is A, B, or rather A map to B, B map to C, C map to D, and D is mapped to C, where A is equal to A, B, C, D, and E, and B is equal to B, C. Option C is 1, -2, 1 is mapped to 2, 3 is mapped to 7, 4 is mapped to -6, and 8 is mapped to 1. Where I don't think it was a wise choice to write all these things down. But anyways, okay, where A is equal to this and B, because there's no more space down here. I'll use the second word, and B is equal to -2, 7, -6, 1, 2. Okay. Option E is none of the above. While option D is mapped to -1, 2 is mapped to -2, is mapped to -3, and 4 is mapped to -4. Rather, 4 is mapped to -4, and 5 is mapped to -5. Okay, where A is equal to 0, 1, 2, 3, 4, 5, and B is equal to, well, they don't even give B, they said A again, A, but let's say it's typo, let's just assume that it's typo, and it's supposed to be B. Is equal to -1, -2, -3, -4, -5. Good. Now, before I tell you the answer and tell you why the other options are wrong, I want to give a little bit introduction to the question. The question says, which of the following relations is a function from A to B? That means A is mapped to B. A is our domain, while B is our range. No, A is our domain, while B is our codomain. It is the domain mapped to codomain. The domain is not necessarily mapped to range because there may be other elements in the codomain that are not inside the range. So the domain is mapped to the codomain. What this means is that, number one, every element in your domain must have an image. Every element in A must be mapped to an element in B. Every husband, this is wrong because this thing means that this, let me just say, but this is like the easiest way that I've seen and most people understand it. Every husband A must have a wife B. Good. But it is not necessary, it is not compulsory for every wife to have a husband. You can see that, okay, let us say that every husband must have a woman, but it's not necessary for every woman to have a husband because there are some women that are still young. That is, not all of them yet are of age to marry. So I think that's like the two main rules. So let us go over it. You can see that there's one ahead. Every husband must also have only one wife. Every husband must only have one wife. I forgot that. Every husband must have one wife. So if you look at it here, person one, let's call him Ebuka. Ebuka is married to one wife, 0. Ebuka again is married to -1. You can see it contradicts. Ebuka must only have one wife. So option A is wrong. The second thing you should check, let's go to option B now. A is mapped to B, B is mapped to C, C is mapped to, and D is mapped to C. Let's go over that. A has only one wife, B only has only one, C has only one, and D has only one. So he checks the first rule. Let's check the second rule. The second rule is that this is what they call it. Every element, every husband must have a wife. We've checked the first rule. Every husband there has only one wife. Every husband has only one wife. So now let's check the second rule. Every husband must have a wife. Let's check the amount of husbands they have. There is A, B, C, D, and E. There are 5 husbands. But how many of them have wife? 1, 2, 3, and 4. Only 4 has wife. So let's check for the fifth one that does not have a wife. A, B, C, D. E does not have a wife. So since E does not have an image, a wife, since E does not have an image, that is the wife, then that means this is not a function. Every husband, first of all, every husband must have only one wife. Every husband must have only one wife. Second of all, every husband must have a wife. So B is wrong. In fact, there's a third one. The wife that they have must be inside the amount of girls in that universe. So let us say B has B and C. And here there's B, C, B, C. But let us say here instead of C, I change here to F. So you can see that D is married to F. But F is not part of the girls in that universe. So that means F is either a robot or is transgender or it's not supposed to exist. So since D has a fake wife, this will also not be a function. So that's the third rule. First of all, every husband must have only one wife. Second of all, each husband must have a wife. First of all, every husband must have only one wife. Second of all, each husband must have one wife. I'm missing it up. First of all, every husband must have one wife, only one wife. Second of all, each husband must have a wife. Third of all, each wife in that place, each wife that a husband have must be part of the amount of good. So I think after I just explained that to the best I can. Please, in case you still understand, please, I believe you can watch some TikTok videos on it, or there are some other YouTube videos that explain it, that may explain it than I did. You can also meet me in person in case you have maybe you are still confused about one thing or another, or you can Google the chat. But I believe I've explained it the best I can. Okay, option C. We have 1 is mapped to -2, 3 is mapped to only 7, 4 is mapped to only -6, and 8 is mapped to only 1. So it's correct. That passed the first rule. Each husband only has one wife. Let's check the second rule. Let's confirm that each husband universe has a wife. 1, 3, 4, 8. 1, 3, 4, 8. It passed the second rule. Each husband there has a wife. And each husband there, and every husband is mapped. Okay. Let's check the third rule now. The third rule says that each of the wife must be part of the universe. We have -2, 7, -6, and 1. -2, 7, -6, and 1. Good. So every wife there part of the universe. So option C is correct. I know some of you will ask me, but there's 2. What happens to the 2? As I said before, there are some immature girls that are not yet ripe for marriage. That is what 2 is. 2 is not yet ripe for marriage. So this is still function. Good. Now let's check option D to verify. If you look at option D now, there is 0 part of our husband, but 0 is not mapped. 1 is mapped, 2 is mapped, 3 is mapped, 4 is mapped, 5 is mapped. But in the amount of husband there's 0, 1, 2, 3, 4, 5. So since 0 is not mapped, option is wrong. So I believe that brings us to the end of this question. The correct answer is C, option C. Okay, so this is question 1, option C. Let's go to the next question, question 2. Question 2. Question 2 is a question I feel. So let's just, you actually came out in test. I got the correct answer in test. I don't know why I now end up failing it in the exam. Okay. But this is the I'll tell you the reason why I failed the question though. And so it's to help you so you not later can mistake again. Question 2. We have the curve y is equal to x squared plus 1 divided by x minus 1 has a normal line at the point where x equals to 2. When I read that question, I only read the normal line at x equals to 2. So I went to go and solve for the normal line. But when you read a little bit further, they will not tell you it has a normal line at x at the point where x equals to 2. But we should find the equation of the tangent line at this point. You can see, always read the complete question. Because me, I only read part of it. Has a normal line at the point where x equals to 2. Immediately I went to find the normal line. But the complete question says find the equation of the tangent line at this point. So we're supposed to find the tangent line and not the line. Now, how do you find the tangent line? First of all, you need to find its gradient. Second of all, you need a point where that gradient passes through. Good. So now you can get the point where it passes through from the question. It says it passes through the point where x equals to 2. So let's value of y when x equals to 2. This is making noise. Even though we're angry. Okay. This is my weight. When x equals to 2, y is going to equal to 2 squared plus 1 divided by 2 minus 1. This is equal to 4 plus 1 divided by 1, which is equal to 5. So when x equals to 2, y is equal to 5. That means the point we're looking for is 2, 5. That is when x equals to 2, y is equal to 5, 2, 5. So now the second thing we need is our gradient. Because let's check the formula. Y minus y1 is equal to m1 times x minus x1. So we have found the point x1 and y1. So we need the gradient m1. How do you find the gradient? Don't forget that m is equal to the change in y divided by change in x. Good. So how do you find the y dx? That is the y dx, change in y, change in x. Instantaneously, this is equal to, that is basically just the limit as change in x tends towards 0. This is equal to the y dx. So how do you find the value of the y dx? It's easy. You differentiate this. I'm going to use this. I'm going to do this using 2 methods to help people. There are people that learn it using whichever method. I'll first of all use the simpler one, which some of you may argue with me and say is not the simpler one. But I'm going to show you that it's actually the simpler one. I'll divide this body into 2. I'll first of all do the one that you already know, which is quotient rule. So let's find using quotient rule. Y dx is going to equal to square of the numerator. And the numerator here, differentiate the numerator, that's 2x. Plus, no minus the numerator, x squared plus 1. Then differentiate the denominator. If you differentiate the denominator, you're going to have 1. So x squared plus 1 times 1 is just x squared plus 1. So now if you simplify, this is going to equal to 2x squared minus 2x. 2x squared minus 2x minus x squared minus 1 divided by x minus 1 all squared. This is equal to x squared minus 2x minus 1 divided by x minus 1 all squared. When x is equal to 2, we want to find the gradient when x equals to 2. When x equals to 2, this is going to equal to 4 minus 1 divided by 2 minus 1 all squared. This is equal to 0 minus 1 divided by 1 squared. This is equal to minus 1, negative 1. Now let me show you the easier method, which some of you may argue is actually harder, but it's actually easier. If you multiply both sides, this will be y times x minus 1 is equal to x squared plus 1. Then differentiate it implicitly. You keep y constant, differentiate x minus 1, you have 1. Plus, you keep x minus 1 constant, differentiate y, you have dy dx. Is equal to, differentiate x squared plus 1, you have 2x. Simplify, you have dy dx is equal to 2x minus 1, sorry, minus y, 2x minus y divided by x minus 1. Now, if you put y is equal to x squared plus 1 divided by x minus 1, you get this same equation here. Right? You get the same equation here. But since I've already written down here, there's no need for you to put y is equal to all this. Instead, you put y is equal to 5 because I already found what y is at that point. Y is equal to 5. So the y dx is going to equal to 2 times 2 minus 5 divided by 2 minus 1. This is equal to 4 minus 5 divided by 1, which is equal to negative 1. Now let's count. This is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. Okay, it's basically the same number of lines, but I just want to put it out there that I still feel the only reason why this method has the same number of lines is because of I've already done it before. So I've already jumped some steps. Yeah, and I don't jump any step. I showed the full working. Yeah, I'm very sure I could have jumped a lot of steps here. That's why here may look shorter. But just look at it now. Tell me, this one actually looks simpler to me. But anytime I tell people that this method I follow, they always be like, why did I follow this long method? I don't know that this was actually easier than this one, but whichever one is mass, you still get the same answer. The gradient is equal to negative 1. Mass is homogeneous. You cannot use the correct method and get the wrong answer. That's the beauty of mass. And if you get a wrong answer, just know that like if two people tell you that this method I use is correct and you still get the answer, that means there may be something hidden, something special in that question that by the time you work harder on it, you now discover your own branch of mass. Maybe there's one conjecture, one guys, I've gotten this proof by, I think, like there's this proof that you prove it by contradiction. That is counter. If you provide a counter example, let's say me now I have a hypothesis that all primes are odd except for 2. Then you now come and prove that okay, there's a prime number that's actually even. You understand what I mean? So it's a proof by contradiction. So if you have something like math that you use 2 different methods, 2 different correct methods, and giving you 2 different answers, you can go and work on your research paper and then tell them that you have found a proof by contradiction that this method is not 100% correct in every. You understand what I mean? It's not 100% correct in every branch of math. And I believe they can award you your medal. But anyways, let's just continue with this. We have found our gradient, so we can put it inside our formula. This is y minus 5 is equal to our gradient negative 1 times x minus 2. This is y minus 5 is equal to negative x plus 2. Okay, let's check our options because it's OBJ, so you have to check your options to see that you see that the moment they put it in the way that you have it here. Because I'm not just saying like, okay, this is my answer, and I'm not selecting that option and I leave it like that. But you're supposed to follow it in line with the examiner. So I check it here. I said, okay, they went further. They moved this left hand side to the right hand side. So that will be y plus x minus 7. Y plus x minus 5 minus 2, that is minus 7 is equal to 0. So we have y plus x minus 7, and that is equal to option D. So we have option D as correct as correct option. Question 2, we have option D. Let me take out my handkerchief. Okay. I'm not even taking my hand drop yet. I'm coming, please. But anyways, we'll go to question 3 now. Question 3 is an integral. Very nice integral. Okay. Question 3 is an integral. So we should find the integral of the sine to the power of 5x cos x. Whenever I see that, we already know that the method we are going to use is u substitution. Yeah. We'll apply u substitution here to make our work easier. So we have the integral of sine to the power of 5x cos x dx. When I see this, I note that if I make u equal to sine x, then what we have here is u to the power of 5. But how will we move this cos x dx? If u is equal to sine x and you differentiate both sides, you're going to have cos x dx. So this cos x dx will also disappear. So let's use that method. Let u equal to sine x. So people can decide to use integration by parts. I've never actually tried that, but I believe it may work. It may work. But let me not start experimenting now with this to avoid getting too long. But let u equal to sine x. Then the u is going to equal to cos x dx. Now, how do you have the u is equal to cos x dx? Some of you may start fighting. How? Just find if you differentiate both sides, you're going to have the u dx is equal to cos x. Multiply this dx by cos x, then you have the u is equal to cos x dx. It's the same thing. So the u is equal to cos x dx. So now you can apply this u substitution here. We have the integral of u to the power of 5 cos x dx is equal to u. Now, how do you integrate this? Remember, you put 1 to the power divided by that new power. So this will equal to u to the power of 6 divided by 6 plus the integral constant of integration. Remember, u is equal to something. U is equal to sine x. So this is equal to sine to the power of 6x divided by 6 plus c, which is the integral constant. And this corresponds to option E. But the problem around this is that it is not exactly the same. Remember, as I said, they are put in the form that the examiner put it. And this is going to be 1 over 6 sine to the power of 6x plus c. But it's still the same thing. But like, you get what I mean? You have to follow the way the examiner put it. So don't come and see the option and be like, it's not the exact same as the one I wrote down here. They are still similar. They're the same thing. Yeah, basically the same thing. They're equivalent. I think that's the word. They're equivalent to each other. So we have option E. Yeah. Yes, we have option E. Question 3, we have E. Let's go to question 4 now. Question 4 says we should find determine interval on which f of x is decreasing. For a function to be decreasing, let me draw a function. What does it mean if I draw a line like this? It means that function is increasing, right? Now, for a thing to decrease, it's going to go like this, right? Then for a thing to increase again, it's going to curve like this. Good. But for a function f of x to be increasing, determine the interval. Okay, decreasing. For a function to be decreasing, it means that curve is going down like this. Now, what does it mean for a curve to go down like this? It means its gradient dy dx is less than 0. If dy dx is equal to 0, then the curve will move like this. If dy dx is greater than 0, it's positive, then the curve will move like this. If dy dx is less than 0, it's negative, the curve will look like this. So negative equal to 0, positive. The same thing happens here. We have positive equal to 0 instantaneously at this point, then negative equal to 0 at this point, then positive. Stay there. No, I told you don't come by two. Don't come when I'm doing my life. Don't come now. So now we're finding the interval that this function f of x is equal to x to the power of 3 minus 6x squared plus 9x plus 1. We're trying to find when this function is decreasing. When it's decreasing, its gradient is less than 0. So let's solve for that. F of x, well, instead of f of x, let's y equals f of x. Then y is going to equal to x to the power of 3 minus 6x squared plus 9x plus 1. So we want to find the y dx. So you're differentiating the left hand side and the right hand side. The y dx is going to equal to 3x squared minus 12x plus 9. So what are we finding for when it's decreasing? That means 3x squared minus 12x plus 9 is going to be less than 0. Divide both sides by 3. You have x squared minus 12x. No. You have x squared minus 4x plus 3 is less than 0. Factorize this. You have x squared minus 3x minus x plus 3 is less than 0. You have x bracket to put x minus 3 plus minus 1 bracket to put x minus 3 is less than 0. This simplifies all through. Let's just clean this. This simplifies to x minus 1 times x minus 3 is less than 0. I think that's what I want to use this space here. So now we have x minus 1 times x minus 3. That means x is equal to 1 and 3. So what's the less one? What's the lesser one? The lesser one is x is equal to 1. So the first interval that we have is x is less than 1. The next interval is 1 to the next number. That is 1 is less than x is less than 3. That is 1 to 3. The last interval we have is 3 to infinity. So that is x is greater than 3. Now, what are the numbers that what's the numbers that we're dealing with? The first number we're dealing with is x minus 1. The next number is x minus 3. Then the last thing is the product of x minus 1 and x minus 3. So this is the table we are going to draw. You always draw this table. So learn this. You always draw this table whenever you are trying to find when you are trying to find solve for inequalities, quadratic inequalities. Okay. Okay. So you're going to need this whenever you're solving quadratic inequalities. Okay, when x is less than 1, x minus 1 will be less than 0. So this will be negative. Anything less than 0 is negative, so this is negative. When x is less than 1, x minus 3 will be less than 2. So this is negative. When x is between 1 and 3, x minus 1 will be between 0 and 2. So this will be positive. When x is between 1 and 3, x minus 3 will be between negative 1 and 0. So this will be negative. When x is greater than 3, what's x minus 1? Greater than 2. Because I'm going to subtract 1 from both sides. So this will be greater than 2, that's positive. When x is greater than 3, x minus 3 will be what? Greater than 0. Because by the time you subtract 3 from both sides, you're going to have greater than 0. So that will be positive. Now what's the product? The product, negative and negative, is positive. Positive and negative, that is negative. And positive and positive, that is positive. Yeah, positive. I'm saying positive because I used to watch Red Pen, Blue Pen. That is Chinese. So he, you know, for instance, Chinese people, like, he used to say, instead of saying positive times positive, he used to say negative and positive and positive. He say positive and positive. Yeah, so he does not say the BE. That's why all true things. When I started watching the video, I've started absorb that character. I don't say positive again. I say positive and positive. But anyways, so now we have positive, negative, and positive. We're looking for when x minus 1 times x minus 3 when the product is less than 0. But if something is less than 0, what is it? It's negative. So we're looking for this negative. And what is mapped to negative? 1 is less than x less than 3. So this is our answer. 1 is less than x less than 3. So that means at the interval when x between 1 and 3, this our curve will be decreasing. It's going to take a hell of time for me to open my do sharing on my screen, and start plotting the graph on my laptop graph. And this device, this my other tablet, is what I'm using for audio. So I cannot really show you the graphic of how the curve will look like. But you can go to your your calculator, your graphical calculator, and plug in x power of 3, plug in this function, and then plug in this function, you're going to have the graph. And from what I'm seeing here, that graph will look something like this. First of all, increase, then to decrease, then increase again. This interval where it start increasing will start from 1 and to end at 3. Then it continue increasing again and like this. This is what it looks like. But from this alone, I cannot tell you where the x-axis is. I cannot tell you where the x-axis is. Because that's like I cannot tell you that kind of bush, but I can only tell you how the curve will increase and decrease from this information here. But anyways, I believe that's the end of this. I can move on to the next part. Yeah, that's the video. Maybe this. The next question is, oh hey, question 4. I've not finished solving myself. I've not finished solving. I went to clean the board. But I remember the answer. 1 is less than x less than 3. This is our answer. So how do you put it in the way the lecturer put it here? We are going to use brackets, and those brackets are come in 2 ways. This is for less than. This is for less than or equal to. This is for strictly less than. Let me try and do it on the truth table. This is inequality, and this is the bracket. For less than, it is this. For less than or equal to, we have this. For greater than, we have this. And for greater than or equal to, we have this. So when 1 is less than x less than 3, we have this. So first of all, we have 1 is less than x. So this will be this like this. 1, comma. Then we have x is less than 3. Since x is on the right hand side, you use 3 is greater than x. So we have this 3 and this. 3 is greater than x. So we have greater than. So we are going to use the circle bracket. Let's assume that the answer was this. Let's assume that the answer was this. Then what you are going to write is square bracket 1, comma 3 circle bracket. But since it is 1 is strictly less than x, strictly less than 3, then we are going to have only this one. And that corresponds to option B, 1 to 3, where 1 and 3 are not included. Question 4, option B. Let's quickly go to question 5 now. Yeah, let's hit. Okay. Question 5. Question 5 says, what is the codomain of the function f mapped to a and b? F mapped from a to b, defined by blah blah blah. Oh. I'm not going to make the mistake of writing down all these things the way I did for question 1. So I'm not going to read it out. What is the codomain? Now, what's the codomain? A codomain is the set that is mapped to. The codomain is the set that your domain is mapped to. Good. So when you have A is mapped to B, then that whole set B is your codomain. Good. So what is the codomain of the function f mapped from A to B? Defined by a, 1, that's A mapped to 1, B is mapped to 3, and C is mapped to 5. A is mapped to 1, B is mapped to 3, and C is mapped to 5. So your range is 1, 3, and 5. But that information alone does not tell you your codomain. Let's read further. Where A is equal to ABC, that is your domain, and B is equal to 1, 2, 3, 4, and 5, that is your codomain. The whole set B is your codomain. But your range is just 1, 3, and 5. But that whole set B is your codomain. 1, 2, 3, 4, and 5. So your answer is option A. 1, 2, 3, 4, and 5. Answer is option A. Question 5 is option A. And let me just check the option and tell you what the many options are. Option A is your range, is your codomain. Option B is your domain. Option C is your range. Option D is the set, the number of things that option D does not have a meaning. It's basically the elements that are in option the elements that are in your domain that are not in your range does not have a name, does not have a name. But the mathematically it is your codomain minus your range. Your codomain minus your range. That is what option D is. But it does not have a name in mathematics. Option 6, question 6 says we should evaluate the integral. We should evaluate the integral from 0 to 2 of 2x to the power of 3 minus 3x squared plus x with respect to x. So we have the integral. Let me check if it's showing on the board because I want to use this. Let me just use the bright marker. The integral from we have the integral from 0 to 2 of 2x power of 3 minus 3x squared plus x with respect to x. Good. So now the way we evaluate definite integral is the same way we evaluate indefinite integral. So just integrate in the normal way. And we have 2x to the power of 4 divided by 4. 2 here 1, 2 here 2. Minus 3x to the power of 3 divided by 3. 3 divided by 3 is just x to the power of 2 plus x squared divided by 2. Now we're evaluating this from 0 to 2. When this is equal to 0, remember it is the upper limit minus the lower limit. So by the time you evaluate the lower limit and you put 0 to this, everything will be equal to 0. So there's no need for you to evaluate the lower limit because it's still going to be 0. So the upper limit, let's evaluate only the upper limit. So this is going to equal to 2 to the power of 4 divided by 2 minus 2 to the power of 3 plus 2 squared divided by 2. This is equal to 2 to the power of 4 is 16. 16 divided by 2 is 8. Minus 2 to the power of 3, 2 to the power of 3 is 8. Plus 2 squared, 2 squared is 4. 4 divided by 2 is 2. So this is 8 minus 8, that is 0, plus 2. So your answer is equal to 2. And this is equivalent to option B. Question 6, we have B. I believe that is quite understandable. So option B, we have question 6, we have B. And the integral is equal to 2. Let's go to the next question quickly. Question 7. Question 7 says if y is equal to x to the power of sine x, we should find the derivative of y respect to x divided by y. Remember in this question, they're not supposed to find the y dx. They are supposed to find the y dx divided by y. To solve this, I'm going to use logarithmic differentiation. That is applying using the laws of logarithm to solve this derivative. Now let's take the logarithm, the natural log of both sides. If you take the natural log of both sides, I'm going to have the natural log of y is equal to the natural log of x to the power of sine x. When you have the natural log of a to the power of b, it's going to equal to b times the natural log of a. So I'm going to apply this law here. So the natural log of x to the power of sine x is the same thing as sine x times natural log of x. I don't know if that's understood. We have x to the power of sine x. The natural log of x to the power of sine x is same as sine x times natural log of x. Now let's take the derivative of both sides. If you differentiate both sides, you are going to have 1 over y times dy dx. Or you can say that 1 over y times y prime. Because y prime is equal to dy dx. This should be equal to the derivative of sine x times the natural log of x. How do you differentiate that? We're going to use product rule. So you are going to keep sine x constant, differentiate ln x. When you differentiate ln x, you're going to have 1 over x plus keep ln x constant, differentiate sine x. If you differentiate sine x, you're going to have cos x. So this will be ln x times cos x. So y prime divided by y is going to equal to sine x divided by x plus cos x ln x. And this is our final answer. Sine x divided by x plus cos x ln x. And that corresponds to option E. Option E. Question 8. The domain of the function f of x is equal to, okay, the domain of the function f of x is equal to 1 over square root of x squared plus x squared minus 3x plus 2 is dash. Let me take this off. You can see I'm already sweating my whole body. But there's no fan here, or that the fan stopped rotating. But we don't find the domain of this function. The function is f of x is equal to 1 divided by the square root of x squared minus 3x plus 2. Now, how do you find the domain? The domain, since this is in the real world, the domain will be the whole real numbers minus when this function will be undefined. When is this function undefined? First of all, when the denominator is equal to 0. Second of all, when you have a negative square root. So let's solve for that. The first case is when the denominator is equal to 0. When the denominator is equal to 0, then the square root of x squared minus 3x plus 2 is equal to 0. So basically, what we want is that this should not equal to 0. Because when it's equal to 0, we have it's going to be undefined. So this should not equal to 0. The second case is when x squared minus 3x plus 2 is less than 0. Less than or equal to 0. We don't want this to be less than, well, you don't want it to be less than 0. Basically, we don't want it to be less than 0. So now we have to, first of all, this should be greater than 0. First of all, this should be greater than 0. This one, yes, this should be greater than 0. If I'm greater than or equal to 0, this should be greater than or equal to 0, and this should not equal to 0. So we can clean things up. We can clean 1 and add it to number 2 by cleaning this equal to sign. So the first case, we have x squared minus 3x plus 2 should not equal to 0. The second case, we have x squared minus 3x plus 2 should be greater than or equal to 0. So since we have equal to 0 and not equal to 0, we can cancel them out and clean the equal to sign. So we have x squared minus 3x plus 2 should be strictly greater than 0. Now, when this x squared minus 3x plus 2 is strictly greater than 0, let's solve for that. You solve for that by rationalizing. So we have x squared minus 2x minus x plus 2 is strictly greater than 0. We have x bracket open x minus 2 minus 1 bracket open x minus 2 is strictly greater than 0. So what we have here, let me clean this here. What we have here is x minus 1 times x minus 2 should be strictly greater than 0. So since we have x is equal to 1 and 2, we can write down here that x is less than 1, 1 is less than x is less than 2, and x is greater than 2. The interval is being evaluated by x minus 1, also being evaluated by x minus 2, and finally by their product. When x is less than 1, x minus 1 will be less than 0. This is negative. This is negative. I've done this before, so there's no need for me to click again. This is going to be positive, this is negative, and this positive, finally this positive. Their product will be positive, negative, and positive. But in this case, last time we were solving for less than 0. This time we're solving for greater than 0. And when something is greater than 0, it is positive and positive. So these are the two cases that we're looking for when it is when x is less than 1 and when x is greater than 2. So I can clean all this here. We have our answer to be x is less than 1 and x is greater than 2. Okay. Now remember, when we have x is less than 1, what is the lower limit? Negative infinity. So this is actually the same thing as negative infinity is less than x less than 1. And or the union of x is greater than 2. When x is greater than 2, what is the upper limit? Positive infinity. So you can say 2 is less than x less than positive infinity. You can see here we have x greater than 2. It's same as 2 is less than x. Good. But since x cannot be greater than infinity, the infinity is our upper limit. X can also equal to infinity. So infinity is like our upper limit and is not equal to infinity. So we have strictly less than infinity. Good. So remember when we have this less than sign, it is circle bracket, negative infinity, comma, 1, circle bracket again. Here we have circle bracket, 2, comma, positive infinity, circle bracket again. And what is joining them? Union. So this is union right here. So this corresponds to option C. Negative infinity to 1, union 2 to positive infinity. And that gives us our correct answer, option C. Question 8, option C. Let's quickly go to question 9 now. Question 9 says we should evaluate the integral I is equal to the square root of 16 minus x squared. I is equal to integral of the square root of 16 minus x squared dx. To solve this, I'm going to apply trigonometric substitution. That is the easiest method to solve it. And which trigonometric substitution are we going to use? We are going to use sine and cos. We'll use sine. Now, how do we know which one we're going to use? I've actually explained this in another video, so please go and check the test review. I've explained this. I make sure I explain this very well in the test review. Check the test review. Oh my God, I put much in. Check the test review and you find out why we did this. I drew some triangles to show you why we use specific integrals when doing trig substitution. So in this example, I'm not going to use tan. I'm not going to use cot. I'm not going to use cosec. For this example, I'm going to use either cos or sine. So I explained that in the previous in another video, so you can go and check that video out. Test review. MTH 1 to 2. This MTH. They're doing the test review. I'll that video to find out how to solve or how to which one you're going to use for each case, each trigonometric case. Oh my God, it's coming worse. But anyways, let's continue. So we'll say let x equal to 16, rather the square root of 16 sine theta. So what this implies to? This implies to let x equal to 4 sine theta. Equal to sine theta. What's dx? Dx would be equal to cos theta d theta. So now let's apply our trigonometric substitution here. This will be the integral of the square root of 16 minus 4 sine theta all squared. That will be taken as 16 sine square theta. Dx is equal to 4 cos theta d theta. So here we have the square root of 16 minus sine square theta. What is 1 minus sine square theta? You can remember this, that 1 minus sine square theta is equal to cos square theta. Multiply this by 16 minus 16 sine square theta is going to equal to 16 cos square theta. So this was 16 minus 16 cos sine square theta. You will just write 16 cos square theta. And since we have square root 16 cos square theta, we can simplify this again to 4 cos theta. So here we have the integral of 4 cos theta times 4 cos theta d theta. You can simplify that, bring them together, marry them together, and we have the integral of 16 cos square theta. We already know what the integral of cos square theta is. But in case you don't know, let's find it out. Now, what is cos 2 theta? Cos 2 theta is equal to 2 cos square theta minus 1. If you simplify this, you are going to have here will be plus 1 And finally, you have cos squared theta is equal to 1 plus cos. No, no, no. Let's say is equal to cos 2 theta plus 1 divided by 2. Same thing. I'm just say 1 plus cos 2 theta divided by 2. But let's say cos 2 theta plus 1 divided by 2. I just want this one to be on the right hand side. Okay. Um, so now multiply this by 16. If you multiply this by 16, this will be 16 here. 16 times cos 2 theta plus 1 divided by 2, which simplifies to 8 times cos 2 theta plus 1. So I'm not going to put 8 cos 2 theta plus 1 into this integral. So we have 8 times cos 2 theta plus 1 d theta. If we find integral, this will be 8 times cos 2 theta integrates to sine 2 theta divided by 2 plus theta. Multiply all through by 8, you have this going to equal to 4 sine 2 theta plus 8 theta. Sine 2 theta is equal to something. Sine 2 theta is equal to 2 sine theta cos theta. So instead of sine theta, I'm going to write times 2 sine theta cos theta plus 8 theta. 4 times 2 is what? 8. So we have 8 sine theta cos theta plus 8 theta. Sine theta is equal to something. Sine theta is equal to x over 4. Because you can see, you have sine theta, you have x equals to 4 sine theta. So that means sine theta is going to equal to x over 4. So instead of sine theta here, we're going to just put times x over 4. Cos theta is equal to the square root of 1 minus sine squared theta. So that will be equal to the square root of 1 minus x over 4 all squared. This is going to equal to 4 here 1, 4 here 2. Going to equal to 2x times the square root of 1 minus x squared over 16 plus 8 theta. Now what is theta? Since x is equal to 4 sine theta, x over 4 is going to equal to sine theta, which are already shown here. That means theta is going to equal to the sine inverse of x over 4. So this of theta here, we're going to write the sine inverse of x over 4. Good. Now I'm going to simplify this a little bit more by saying let's factor out 1 over 16 from here. 1 over 16 from here, you're going to have divided by 4 outside, and here you're going to have 16, and here you're going to have divided by 1. So this will be 16 minus x squared. 2 divided by 4 is 1 over 2, so this will be x over 2. And this corresponds to option B. I say you're supposed to put it in the way that your examiner put it. So instead of putting it in the way that it's going to be 2x times the square root of 1 minus x squared over 16 plus 8 theta, you can classify it further by saying x over 2 times the square root of 16 minus x squared plus 8 times sine inverse of x over 4. You have to simplify it. You have to put it in the way that the examiner put their own. So this corresponds to option B. Don't forget plus C, integral constant. Question 9 is option B. Yes. So let's go to question 10 now. Question 10 says we should find, okay, the function question. Question 10 says if f of x is equal to x divided by x plus 1, we should find f of a over b divided by f of b over a. Good. So now the first thing we should do is to find f of a over b, then find f of b over a, and divide them by each other. F of x is equal to x times 1 over x plus 1. Therefore, f of a over b is going to equal to a divided by b times 1 over a divided by b plus 1. This is equal to a divided by b times 1 over a divided by b plus b divided by b. because 1 is equal to b divided by b. This can be simplified to 1 divided by a plus b divided by b. So this is just reciprocal. You can change this to simply b divided by a plus b. So here we have b here and we have b numerator. We have b denominator and b numerator. You can cancel each other out. So equal to a divided by a plus b. But since f of a divided by b is equal to a divided by a plus b, then that means f of b over a is going to equal to b divided by a plus b. So f of a over b divided by f of b over a will equal to a divided by a plus b divided by b divided by a plus b, which simplifies to a over b. And this is our final answer, a over b. And that corresponds to option B. Question 10, option B. Let's quickly go to question 11 now. Question 11 says you should find the area of the region enclosed between the curves y is equal to x squared and y is equal to x plus 6 expressed in square units. Good. We should want to find the area of the region enclosed between the curves. So first of all, we have this curve y equals to x squared here. And we also have the next curve or the next line y equals to x plus 6, which should look something like this. So we want to find this area enclosed here. First of all, what do you need to find this area? We need to first of all find the 2 points where they interlock. That means if you find where y is equal to x squared is going to equal to y is equal to x plus 6. Basically, when x squared is equal to x plus 6. This is what we're looking for. And when x squared is equal to x plus 6, that means x squared minus x minus 6 is going to equal to 0. That means x squared minus 3x minus x squared minus 3x plus 2x minus 6 is going to equal to 0. This means that x squared, this means that x times, let me write this down. This means that x times x minus 3 plus 2 times x minus 3 should be equal to 0. This finally implies that x plus 2 times x minus 3 is equal to 0. So the 2 points that they meet is when x is equal to negative 2 and when x is equal to positive 3. Those are the 2 points that we're looking for. So when you want to put in your integral, it's going to be the integral from negative 2 to 3. Now let's continue. One find the area. The area is y1, or the area is going to be from of f of x, f1 of x minus f2 of x. What this means is that we're finding the integral of the function x squared minus x minus 6 with respect to x. So you either carry the first function and subtract the second function, or you carry the second function and subtract the first function. So you can either be x squared minus x minus 6 or x plus 6 minus x squared. It does not really change the answer. Actually, it does change the answer. But since we're finding the absolute value, it will not change the answer. The absolute value will make sure that it's positive. So whatever, even if you get a negative answer, change it to positive. So we're finding the absolute value of this. So how do you find this integral? Remember, like I said the last time, of the definite integral. You first of all find the indefinite integral. How do you find the indefinite integral? This will be x to the power of 3 divided by 3 minus x squared divided by 2 minus 6x. Then you apply the definite integral. The definite integral is from negative 2 to 3. In that last case, here was 0. So I said you should ignore the lower limit because everything will be equal to 0. But since here is not equal to 0, then you need to evaluate the upper limit and the lower limit. So we have the upper limit and the lower limit. The upper limit is going to be 3 to the power of 3 divided by 3 minus 3 squared divided by 2 minus 6 times 3, which is just 18. Minus the lower limit. The lower limit is negative 2 to the power of 3 divided by 3 minus negative 2 squared divided by 2 minus 6 times minus 2 is plus 12. Good. 3 to the power of 3 is 27. 27 divided by 3 is 9. 9 minus 3 squared is 9. So this is 9 minus 9 over 2 minus 18. 9 minus 18 is minus 9. 9 minus 18 is minus 9. So here we have minus 2 to the power of 3 is minus 8. Minus 2 to the power of 2 is 4. 4 divided by 2 is 2. So here we have negative 2 plus 12. That is plus 10. That's positive 10. In case this way that I'm adding and subtracting, step by step is confusing for you. Calculator is not shall allow, so you need to find a way that you can easily add and subtract as quick as possible. And this method has been what I've been using. Adding the whole numbers first to each other, then leaving the fractions. So you can find whichever method that is faster for you. Just remember that our calculator is not allowed. So you cannot expand the bracket. You have negative 9 over 2 minus 9 plus 8 over 3 minus 10. Negative 9 minus 10, that is negative 19. So now you can bring them all under the same denominator. I'm going to clean here so I can solve continuously. If you bring under the same denominator, you have 2 times 3, that is 6. 6 divided by 2 is 3 times 9, that is negative 57. This is plus 16. Minus 9 times 3. Sorry, minus 19 times 3. That is 27. 30, 57. That is negative 57. I can clean all this up. So here we have 27 plus 57. That's 14, 5, 6, 7, 8. So that's 84. So we have negative 84. 16 minus 84. That's 68. So we have negative 68 over 6. Remember, I said the absolute value. So this negative will change to positive. Divide both sides by 3 by 2. You have 34 divided by 3. 34 divided by 3 actually does not look like the answer that I got. So along the way, I must have made one mistake or the other. And I've cleaned the whole board. But what I'm going to just do, I made a mistake somewhere. What I'm just going to do is to try to solve the whole thing again. Let me just confirm to check if we have x squared minus x minus 6. Okay. X to the power of 3 divided by 3. You can also check along to check where I made the mistake. I'm not really sure where I made the mistake from. Okay. X equals to 3. This is 9. Yes. Okay. X power of 3 divided by 3 minus x squared divided by 2 minus 6x. Okay. This is from negative 2 to 3. Okay. When x is equal to positive 3, we have 37 divided by 3 minus 9 divided by 2 minus 3 times this is 18. Okay. This is going to be 9. 9 minus 18 is negative 9. Okay. Minus negative times this is going to be minus 8 divided by 3 minus this here is going to be 4 divided by 3 negative 2 plus 12. This here will be plus 10. Okay. This will be negative 9 over 2 minus 9 plus 8 over 3 minus 10. Okay, minus 9 minus 10, that's minus 19. I think this is exactly the same as the last one I just did now. Divided by 6 here. This will be minus 27 plus 16. Wait, oh, I think I just saw it. I did 19 times 3 that last time. It's supposed to be 19 times 6. Because here we have the root of 6. I think that last time I did 19 times 3. That is the error. It's supposed to be 19 times 6. That's the error. 19 times 6. 19 times 6, this is 54. This is going to be 11, 114. So it will be minus 114. So it's the exact same process again. So remember in the example, try your best not to make mistakes. All these errors, they can slow you down. All these errors, they can slow you down. But it's good to have this kind of errors that they are not winning the option at all. So you know, yes, make the count. But if you have that kind of error that you are seeing your answer inside the option, you will not be tempted to pick it without cross-checking. So it's good that you have this kind of error that you can easily verify that you made a mistake and you can go back and cross-check. So the example two, try your best to be solving that in a way that you can go back and revisit to check if you made a mistake. Not the way that I solve now, I'll solve, I misclean. Try to solve finish before cross-check is cross-check. Make sure you don't make a mistake before you put your answer down. So yeah. So here we have 114 plus 27. That would be 11 4 141. Then minus 16. That will be 5 to 125. That will be negative 125 divided by 6. Remember, it's the absolute value, so this negative becomes positive. So we have 125 divided by 6. And this is our correct answer. And this corresponds to option D. 125 divided by 6 square units. Option D. Question 11, we have D. Let's go to question 12 now. Question 12 says, let f of x equal to x to the power of 3 minus 12x plus 5. X power of 3 minus 12x plus 5. The x coordinate of the local extrema are, okay, what are the extremas? Extremas, the local extremas are points on a graph where like the surrounding, like the local maximum is a point on the graph that is greater than the surrounding values. Let me just plot something. When you have a graph like this is the local maximum. This is not the global maximum. The global maximum is at infinity. That infinity. But this is the local maximum. Then this is the local minimum. The actual minimum is at negative infinity. But that is the global minimum. The global minimum is the lowest number in the whole graph. But this is the lowest number around itself. This is the maximum number around itself. So this is the local maximum, the local minimum. Together, they are the local extrema values. They are the local extreme values. What do you notice about these values, about this point? At this point, the gradient is equal to 0. At this point, instantaneously, at this point, the gradient becomes 0. It was positive here, it turns negative here, then positive here. But at this point, this is the transition point, it becomes negative at this point here. So when you want to find the local maximum or minimum, the derivative at that point should be equal to 0. So let y equals f of x. If y is equal to f of x, then y is going to equal to x to the power of 3 minus x plus 5. So we want to find dy dx. The derivative of y respect to x is going to equal to 3x squared minus 12x. No, 3x squared minus 12 plus 0. And this is going to equal to 0 because remember I said the derivative is going to equal to 0. So you have 3x squared minus 12x is going to equal to 0. This implies that 3x squared is going to equal to 12. That means x squared is equal to 4. That means x is equal to the square root of 4. Plus minus, the positive or negative. So x is going to equal to plus 2 or minus 2. And this is our minimum point. Maximum or minimum. They don't also specify which one is the maximum or which one is the minimum. But just at these 2 points, you have the extreme values. One of them will be the maximum point, one of them will be the minimum point. And that corresponds to option E, -2 and +2. Option E. Let's go to question 13. Question 13 says we should find the derivative of tan inverse of 3x. Find the derivative of tan inverse of 3x with respect to x. To solve this, I'm going to make, first of all, say let something equal to something. Let y equal to tan inverse of 3x. So what we're looking for is dy dx. Good. So y is equal to tan inverse of 3x. Then that means tan y is equal to 3x. Find the tangent of both sides, and y is going to equal to 3x. Differentiate both sides, you have sec square y dy dx is equal to 3. Good. Now remember, we're looking for dy dx, not sec square y dy dx. So divide both sides by sec square y. You have dy dx, which is what we're looking for, is equal to 3 divided by sec square y. But remember, dy dx is mostly in terms of only x. So we want to make this sec square y equal to something that has only x. Now, how do we make y relate to x? Remember, tan y is equal to 3x. But this is not tan y that is here. But remember that tan y, remember that tan square y plus 1 is equal to sec square y. Don't forget that. Tan square y plus 1 is equal to sec square y. That means sec square y is actually going to equal to 1 plus tan square y. And what's tan y? Tan y is equal to 3x. So tan square y is equal to 3x all squared. You can simplify this, but first of all, we want to look at the way that lecturer put their own answer. Okay, the way they put their own answer is not like they expanded it. So this is going to be equal to 3 divided by 1 plus 9x squared. And this corresponds to option A. No, option B. Option A is 1 divided by 1 plus 9x squared, which is wrong. Option B is the correct one. 3 divided by 1 plus 9x squared. Option B. So question 13, we have option B. Let's go to question 14. Question 14 says we should find the definite integral. How I wish I wrote down this formula before cleaning it up, because we are still going to find, we're still having the same thing here again. Find the definite integral of pi over 2 from 0 to pi over 2 of cos square x dx. So remember that we found the integral of cos square x dx some time ago. How I wish I wrote it down, but I don't write it down, so we'll have to find it again. I feel like finding it using another different method, but to avoid making this video long, I'll just use the method, which is one I used last time. So remember that cos square x, is equal to cos 2x plus 1 divided by 2. So the integral from 0 to pi over 2 of cos square y will be from of cos 2x plus 1 divided by 2 dx. So this is the same thing as cos 2x divided by 2 plus 1 over 2. If you find the integral, this would be sine 2x divided by 2 times 2, which is 4, plus 1 over 2x. We are plugging in x is equal to, that is from 0 to pi over 2. Remember, when x is equal to 0, this will be 0 plus 0. There's no need for it to plug in x equals to 0. So you're only going to find where x equals to pi over 2. When x equals to pi over 2, this will be sine pi divided by 4. So 1 over 2 times pi over 2. Sine pi, that is sine 180. Do I know what sine 180 is? I know sine 90 is equal to, let me just, I know sine 90 is equal to 1. I know sine 180 is not equal to 0. So sine pi is not equal to 0. 0 divided by 4 is still 0. So this is irrelevant. So your answer is going to equal to pi divided by 4. And that corresponds to option B. Which is option B. Let's go to question 15. Let me see if I can find an lecture that is not making noise. Okay. Well, question 15 now. Question 15 says we should find the integral of x to the power of 3 then x dx. Now to solve this, I'm going to use integration by part. So I'm going to differentiate one of them and integrate one of them. Let u equal to the x. Then du is going to equal to 1 over x dx. Let dv equal to x to the power of 3 dx. Then v will equal to x to the power of 4 over 4. We differentiated one of them and we integrated one of them. Good. So what's your integration by parts formula? You have integral of u dv is equal to uv minus integral of v du. I've already put out some that works in another separate video. Go and check it out. Let me just write down again so I can use u dv minus is equal to uv minus integral of v du. So u is equal to then x and dv is equal to x to the power of 3. So this is x power of 3 then x dx. This will be equal to, this is what we're looking for. This is equal to u times v. That is then x times x power of 4 divided by 4. That is x power of 4 divided by 4 then x minus the integral of v x to the power of 4 divided by 4 times du times 1 over x, which is equal to x power of 4 divided by 4 then x minus the integral of x to the power of 3 divided by 4 dx. This is going to equal to x power of 4 divided by 4 then x minus x to the power of 4 divided by 4 times 4, that is x power of 16. X power, that is 16. You have x power of 4 divided by 4 times this divided by 4 that is here, that is divided by 16. Plus your integral constant. If you simplify this, you have x to the power of 4 divided by 4 then x minus x to the power of 4 divided by 16 plus c. And that corresponds to option C. X power of 4 divided by 4 then x minus x power of 4 divided by 16 plus c. Option C. Question 15, option C. Let's go to question 16 now. Question 16 says we should find the area bounded by the curve y is equal to y squared is equal to 4x and y is equal to x. Most people may say that this question is hard because the way they reason is to integrate with respect to x. But me, I'm not going to reason that way. I'm going to integrate with respect to y because I'm moving. But you go and come answer. You go if you go with respect to x, you go with respect to y. You still have the same answer because we're looking at between two curves. This area does not care where it is. The area of this like me, even if you take it to Jamaica, it still have the same area. Take it to London, still have the same area. Does not care which axis you are integrating with. It is if I am finding the area between this curve and the x-axis, this will have a different area than this area here. But I am finding the area between two curves. It does not care if the x-axis so that you integrate over or the y-axis, we still have the same answer. So since this question is between two curves, and when I'm integrating with respect to x, it's going to be complex. What do? I switch to y. So the first function is y squared is equal to 4x. Instead of saying let y equals the square root of 4x, I'm going to say let x equal to y squared divided by 4. Let x equals y squared divided by 4. And the second function, instead of y is equal to x, I'm going to say let x equal to y. Good. So now what do you need? First of all, you need to find the 2 points that collide. And that is when x is equal to y squared divided by 4 is going to equal to x to y. Therefore, y squared divided by 4 is equal to y. Therefore, y squared is equal to 4y. Therefore, y squared minus 4y is equal to 0. Therefore, y times y minus 4 is equal to 0. Therefore, y is equal to 0 or y is equal to 4. I'm very sure I don't need to explain in depth on how this flows. So the integral that you're looking for is the integral from 0 to 4 of what? Y squared over 4 minus y. With respect to what? With respect to y. I'm integrating around the y-axis now. So this is equal to what? Integrate this integral. Yeah, y to the power of 3 divided by 12 minus y squared divided by 2 from 0 to 4. Since we have 0, there's no need for us to find the lower limit because the lower limit is also going to be 0. 0 to the power of 3 divided by 12 is still 0. 0 to the power of 3 divided by 2 is still 0. So there's no need to find the lower limit. So let's find the upper limit. This will be equal to 4 to the power of 3 divided by 12 minus 4 squared divided by 2. This is equal to 16, 32, 64. This is equal to 64 divided by 12 minus 16 divided by 2. 64 divided by 12 is the same thing as 32 divided by 6. And this is equal to what? 16 divided by 3. Minus what? Minus 8. Instead of minus 8, I can write minus 24 divided by 3. So here we have it is equal to 16 minus 24 divided by 3. 16 minus 24 is the same thing as minus 8 divided by 3. But remember, we're finding the absolute value of it. So even if it's negative, we turn it positive. So our final answer is 8 divided by 3. And this corresponds to option D. Question 16, we have D. 1 hour 30 minutes. Question 17 now. We have if question 17 now, we have if f of x is equal to 1 divided by the square root of 1 plus no. If f of x is equal to x divided by the square root of 1 plus x squared, we should find f of x. I have asked lecturers if we can simplify this function instead of having f of x. Let's simplify it to f3 of x. You understand now? Because of if we have f to the power of 3 of x, this is equal to f of x all to the power of 3. Then when you have f of x, then it should be f subscript 3 of x. It seems more beautiful to write now, but all lecturers I meet, they all tell me, no, it's not the fine way, it's not the right way to write it, it's not the math way to write it. Bro, you're a mathematician, you should invent your own notation. But they all say no. So I'm not going to teach people how to write this. It looks better. Instead of writing, okay, what if I ask to find f of x? To be hard now, I've done you f of, it will be too long. So they should make me split out to say f subscript 5x to be f of x. But it's just me and my own solution. So I'm not going to try to teach people using this because it's possible that in maths this may already be defined as something else. Not that this can be defined as something else. So I'm not going to teach people using this. I'll use the normal f of x that they want. But in future, if I end up being good at maths, better than how I am now, and I write my own textbook, just now this is how I'm going to write it. So let us continue. So now let's first of all, before we can find f of x, we need to find f of x. Before we can find f of x, let's find f of x first. So what is f of x? This is equal to f of x divided by the square root of 1 plus f of x squared. Remember, wherever you see x, you put f of x. F of x divided by the square root of 1 plus f squared of x. So this would be equal to f of x divided by the square root of 1 plus f squared of x. So this is equal to x divided by the square root of 1 plus x squared divided by the square root of 1 plus f squared of x is going to equal to x squared divided by 1 plus x squared. How did I get this? Just square this side, square both sides. You have f squared of x is going to equal to x squared divided by square root of 1 plus x squared all squared is going to be 1 plus x squared. Good. So if you simplify this denominator, you can allow it to by yourself, you will get the simplification. The thing is easy to simplify. You will get 1 plus 2x squared divided by, no, I've forgotten what it was, but divided, okay, I remember now, divided by 1 plus x squared. This is simplified. That one that was on the left hand side, just turn it to 1 plus x squared divided by 1 plus x squared. So now you have 1 plus x squared divided by 1 plus x squared plus x squared divided by 1 plus x squared. In the numerator, you have 1 plus x squared plus x squared. That will give you 1 plus 2x squared. In the numerator does not change, so you have both 1 plus x squared here. This is division. Remember, you turn it to multiplication. First multiplication. Then you now flip this. So you have the square root of 1 plus x squared. You have the square root of 1 plus 2x squared. This here will cancel this here, and you have this is equal to x divided by the square root of 1 plus 2x squared. Sorry. So instead of all this, you just write x divided by the square root of 1 plus 2x squared. So you don't need any of this anymore. So now let's find f of x. This is going to equal to f of x divided by the square root of 1 plus f. Too many f's. You know what? I'll use my own notation. So the f subscript of x is equal to the f subscript 2 of x divided by the square root of 1 plus f subscript 2 squared of x. Good. Simple notation. Simple way of writing it. F sub two of x is equal to f of x, and that is equal to what? X divided by the square root of 1 plus 2x squared divided by the square root of 1 plus, now square f of x, you will get x squared divided by 1 plus 2x squared. The same simplification happens here, and you have 1 plus 3x squared divided by 1 plus 2x squared. Good. If you simplify it further, you're going to have this is equal to x divided by the square root of 1 plus 3x squared. That corresponds to option D. X divided by the square root of 1 plus 3x squared. Question 17, we have D. Let's go to question 18. Question 18 says, given the implicit equation x squared plus xy we have x squared plus xy plus y squared is equal to 7. We should find the derivative at 1, 2, at the point 1, 2. Let's find the derivative function. If we differentiate both sides, you are going to have 2x plus, keep x constant, differentiate y, you are having dy dx, plus, keep y constant, differentiate x, you are just having y, plus 2y dy dx is equal to 0. So now you have x plus 2y times dy dx is equal to negative y minus 2x. We have negative y minus 2x. We move to the left hand side. So now you have dy dx is going to equal to negative y minus 2x divided by x plus 2y. Remember, we're finding this derivative at the point where x is equal to 1 and y is equal to 2. When x is equal to 1 and y is equal to 2, this is going to equal to negative 2 minus 2 bracket 1 divided by 1 plus 2 bracket 2. This is equal to negative 2 minus 2 divided by 1 plus 4, which is equal to negative 4 divided by 5. Negative 4 divided by 5 corresponds to option B. So that 18 is B. Question 19. If y is equal to x to the power of 3, okay, this is an approximation question. And before I introduce 5 complete question, let me just tell you that the limit of change in y over change in x, as change in x tends to 0, is equal to dy dx. This is basically your the first principle of integration of differentiation. First principle of differentiation. The limit of change in y over change in x, as change in x tends to 0, is equal to dy dx. But what if your change in x is not tending towards 0? What if your change in x is actually big, like maybe it's equal to 1 or it's equal to 0.1? It's not actually equal to 0, it's not tending towards 0. Well, that would mean that that change in y over change in x would be approximately equal to dy over dx. That change in y over change in x would be approximately equal to dy over dx. So that means that change in y is approximately equal to dy over dx times change in x. Or you can say change in y is approximately equal to f prime of x times change in x. Whichever way you want to put it. So here we have that f of x is equal to, or that y is equal to x to the power of 3. We should find the approximate change in y when x changes from 2 to 2.01. So if y is equal to x to the power of 3, this implies that dy over dx is equal to 3x squared. And this dy over dx, this is equal to f prime of x. It's the same thing. So change in y, which is what we're looking for, is approximately going to be equal to 3x squared times your change in x. What's your change in x? As x changed from 2 to 2.01, your change in x will be 2.01 minus 2, which is equal to 0.01. So this is approximately equal to 3 times 2 squared times 0.01. This is equal to 3 times 4 times 0.01. This is equal to 12 times 0.01. Let me change this to times, because normally, I started multiplication as dots. So since there's point, let me change this to times. 3 times, let me change this to times also. 3 times 4 times 0.01 is known as 12 times 0.01, which is equal to 0.12. And that corresponds to option C. So question 19, we have option C. Let's go to question 20. Question 20 says, if f of x is equal to sine s cos x, we should find the second integral, the second derivative, sorry. So we have f of x is equal to sine x cos x. Remember that 2 sine x cos x is equal to sine 2x. You can just multiply this using product rule, but I want to just simplify everything, so I'll show you an easier way of finding this integral. So the easier way, we have 2x, 2 times sine x cos x equals sine 2x. That means sine x cos x is equal to sine 2x divided by 2. So we have f of x is equal to sine 2x divided by 2. Now find f prime of x, that is the first derivative. This will be equal to cos 2x divided by 2 times 2. Differentiating normally, we have cos 2x divided by 2. Then multiply by the derivative of the inner function, that's 2. So 2 here 1, 2 here 1, that's equal to cos 2x. That's why when you do this using the product rule, your answer will be cos square x minus sine square x. Tell me this is what you got, because this is what you're supposed to get after finding the first integral using product rule. But now let's find the second derivative. This will be equal to, now we have cos 2x. So it's going to be equal to negative sine 2x times 2, which is equal to negative 2 sine 2x. Now, what's sine 2x? Sine 2x is equal to 2 sine x cos x. So this is equal to negative 4 sine x cos x. So you can still end up with the same answer. Negative 4 sine x cos x, that is equal to option B. Question 20, option B. Question 21 now. We should find the range of f of x is equal to the square root of x plus 1, x plus 2. So we should find the range. Remember that square roots only gives you the positive answer. So we have the square root of x plus 2 can only give you positive answer. F of x is greater than 0. So since f of x should be greater than 0, that means 0 is less than f of x. And that is also less than positive infinity. And how did I tell you how to find these inequalities? This type will become circle bracket 0, positive infinity, circle bracket. And that corresponds to option. Sorry. I just remember something. This square root, right? It can give you 0. It should be greater than 0. It can also be equal to 0. Because if x is equal to negative 2, then you have 0. So it's not just greater than 0, it is greater than or equal to 0. I just remember that. It's greater than or equal to 0. Since it's greater than or equal to 0, you have 0 is less than or equal to f of x, which should be less than infinity. And now we're correct. It should be less than or equal to, not just strictly less than. Good. So we have this type of bracket, 0, comma, infinity, then circle bracket. And this corresponds to option B. Square bracket 0, comma, infinity. Yeah. So option B. Question 22. We have that we should find integral of x times x squared plus 5 to the power of 4 dx. Good. We are going to use u substitution to solve this question. And the u sub I'm going to apply is let u equal to this inner function here. So let u equal to x squared plus 5. Then we have du is going to equal to 2x dx. That means du divided by 2 is equal to x dx. Apply this u substitution here. We have the integral x squared plus 5 to the power of 4 is known as u to the power of 5, power of 4. Then x dx is equal to du divided by 2. So this will be equal to 1 over 2 times u to the power of 5 divided by 5 plus c, which is equal to u to the power of 5 divided by 10 plus c. U to the power of 5 is written as x squared plus 5 divided by power of 5. Here we have x squared plus 5 to the power of 5. So our final answer is x squared plus 5 to the power of 5 divided by 10 plus c. X squared plus 5, no, x squared plus 5 to the power of 5 divided by 10 plus c. And that corresponds to option E. Question 22, we have option E. Question 23 says we should find the area. This is the third area question. So study your areas. Study your areas. Okay. We should find the area between the curve y is equal to x squared and y equals the square root of x. Okay. Now if I look at it now, the first one that we solved, the first one we solved, the area question, I said we're going to solve it with respect to x. The second one, I told you that it's easier to solve it with respect to y. But look at this question. The same turn to x, turn to y, it's the same thing. Because now we have I'll just speak it. We have y is equal to x squared and y is equal to the square root of x. Now, if I want to solve it in terms of with respect to x, then I'm going to solve x squared minus the square root of x. If I want to solve it with respect to y, then if I make everything the x sort of formula, then the first formula, instead of y is equal to x squared, I'm going to have, okay, this is the end of this thing. Oh, 1 ink finished. Actually, I think things are finished. Like this version are finishing at home. All the other ones are finishing in school, not at home. So we have, okay, let me write it. I believe it's better to write it down. So y is equal, bam. So y is equal to x squared and y is equal to the square root of x. If I make x of the formula both sides, I'm going to have the square root of y is equal to x and y squared is equal to x. So you can see it's the same thing. Y is equal to x squared, x equals to y squared, and y is equal to square root of x equals square root of y. So there's no easier one to use. Changing to respect to x and changing to respect to y to still be the same toughness. So there's no change to respect to y. I'm not going to solve it with respect to x. So solving with respect to x, we have that y is equal to x squared and y is equal to the square root of x. So we're looking for when y is equal to x squared equal to y is equal to the square root of x. That means x squared should be equal to the square root of x. If you square both sides, you're going to have x to the power of 4 is equal to x. times x to the power of 4 minus x should equal 0. Times x bracket of x power of 3 minus 1 should equal 0. Times x is equal to 0 or x is equal to 1. X equals to 0 or x equals to 1. So if x equals 0 and x equals to 1, our limit would now be the integral from 0 to 1. The integral from 0 to 1 of x squared minus the square root of x with respect to x. This will be equal to the integral from 0 to 1 of x squared minus x to the power of 1 over 2 with respect to x. This is equal to, if you evaluate the integral, you're going to have x to the power of 3 divided by 3 minus x to the power of 3 over 2 divided by 3 over 2, that is 2 over 3. Yes. From 0 to 1. When x is equal to 0, the lower limit would be equal to 0. So there's no need for us to find the lower limit. We only find the upper limit. The upper limit is equal to 1 divided by 3 minus 2 divided by 3, which is equal to negative 1 over 3. But remember, we are not dealing with the negative answer. So all negative answers change to positive because I find the absolute value. So our final answer is 1 over 3 square units. That's option E. Another thing just came to my head right now. What if instead of square units, all the options there have let me just use options. What if in the options you saw 5 over 12 square units, 2 over 3 square units, 1 over 12 square units, and 1 over 6 square units, and then you now saw 1 over 3 units. You did not see 1 over 3 square units, you saw 1 over 3 units, and it's area that you're finding. The thing is that this lecturer is different from MTH 1 to 3. MTH 1 to 3 lecturer will fail you if you pick 1 over 3 units. Yes, Mr. Bonnie will fail you if you pick 1 over 3 units. You are supposed to pick 1 over 3 square units, and if you don't see 1 over 3 square units, you pick none of the above. But for this case, since this is Dr. Abuala, and Dr. Abuala does not take this kind of questions, does not take those kind of tricky questions, he goes straight to the point. I would advise you to pick 1 over 3 units like that. Just leave the 1 over 3. But in case you saw none of the above in the options, my dear, pick none of the above. After the exam, go and meet the lecturer. Sir, see you in this question, you omitted the square unit, you put only unit. They can actually reason your case and give you the answer as either bonus or they'll give the 2 options as the correct answer. But in case you're not gonna pick 1 over 3 units, they can begin to argue with you and say, oh no, you are completely wrong. This one you have nothing to claim. But for this other one, you can claim and say, but this is mathematically wrong for it to be 1 over 3 units. You understand? There's a time in MTH 111 test 2. You can see that there was question 15. That question 15, I made a separate video on it. I said the notorious question 15 because everybody in the set failed that question. There were only 3 people in the set. That is me and 2 other people that got that question. And it can be that those other 2 people just guess that they guessed the correct answer. Now, I'm not saying that the question was unsolvable. No. It's just that for our level, we've not reached that place yet. Or we've actually reached, because this is something that they taught us since our SS1. But they never giving people something that hard. So it means it's none of their website option to pick none of their above. Now the lecturer at first wanted to pick none of their above as correct answer because that's what most people picked to give people placing mark. But when I don't pick none of the above, then I solved it because I knew how to solve it. So I solved it and I got my answer. So that's what I mean. I said no, that why is the marking guide having none of the above as correct answer? The correct answer is this. He said, but most of you could not solve it. I said no, but sir, I was able to solve it. So would I now lose my own mark because every other person was not able to solve it? That kind of thing. They edited the marking guide and gave the correct answer as the correct, and gave my option as the correct answer. So whenever you are sure that this question is wrong, you can gamble it and put their own option as the correct answer. Or you can decide to be brave, like I was, and solve it the way it's mathematically correct. And go and meet the lecturer and say, sir, there was actually a way to solve it. Though there are times I did that and they did not hear me, they say no, that even if it's that, even if it's blah blah blah, They ended up failing me. So just a gamble is your own choice. All kind of thing. I did all these things just for fun, just to laugh about and let them know that I exist in this set. But it's not. Let me just continue. I beg. It's just my own pleasure. And going to go and meet them and say, "Oh, sir, let's debate about maths. Let's talk about maths." Because I want to see the way they reason and let them see the way me I reason. So just for my own fun. If you're not that kind of person that enjoys talking with your lecturers and gisting with them, then this may not be the type of thing for you. But me, I enjoy it. Let me just continue. The next question is question 24. Okay, I've reached the last page. Question 24. Okay, this is already 2 hours. Okay, same as last. There's one to try. It also took 3 hours to solve that one. So yes, I'm also taking 3 hours. Question 24. They say we should evaluate the integral of 1 over x squared plus 16 dx. We're going to apply some use substitution here. Which use substitution are we going to use? For this particular case, remember the last one we did, we used x is equal to x equals to what did we use last time? We use x is equal to 4 sine theta. For this one, we're going to use x is equal to 4 tan theta. How far? I'm coming. Ooh, keep quiet. Okay. Um. Okay. To solve this question, we are going to apply trigonometric substitution and write x is equal to 4 tan theta. And remember, I said that I already showed you how to get which one you're going to use before. So for this question, I'm going to use x equals 4 tan theta. We have integral of, so when you differentiate, the x will equal to 4 sec square theta d theta. Good. If you apply the integral now, this will be the integral of 1 divided by x squared. So instead of x squared, you're having 4 tan theta all squared plus 16 dx. Instead of dx, you're going to have 4 sec square theta d theta. So this becomes the integral of 1 divided by 16 times square theta plus 16 times 4 sec square theta d theta. Tan square theta plus 1 is equal to sec square theta. As I've seen multiple times. That means 16 times square theta plus 16 is going to equal to 16 sec square theta. Okay. But not show on the video. Not show, just okay. So 16 times square theta plus 16 is going to equal to 16 sec square theta. So instead of 16 times square theta plus 16, I'm going to just change this to 16 sec square theta. You can now cancel some things out. Instead of sec square theta, you cancel sec square theta from here. Instead of 4 here, you cancel 4 from here, you have 4. So now you have integral of 1 over 4 theta. And this is equal to 1 over 4 theta plus c. Okay. Now what is theta? X is equal to 4 tan theta. That means x over 4 is equal to tan theta. Therefore, theta is equal to tan inverse of x over 4. So here we have this is going to be equal to 1 over 4 times the tan inverse of x over 4 plus c. 1 over 4 times the tan inverse of x over 4 plus c. That corresponds to option D. Question 24, we have option D. Question 25 now. We have if f of x is equal to ax, is a pretty long expression. But we have if, okay, this is another question I failed in the exam. F of x is equal to ax divided by x plus 1, and x is not equal to 1. I believe what they wanted to say here was x is not equal to negative 1. But anyway, they said x is not equal to 1, so we'll just leave it as that. And x is not equal to 1. Because when x is not equal to negative 1, then here will not be able to divide by 0, which it sounds like a reasonable thing for them to have seen. When they say x is not equal to 1, we'll just leave it like that. Put that on charge. Okay. What is the value of a so that what's the value of a, so that f of x is equal to x. What's the value for what value of a would f of x equal to x? Now let us first of all find what f of x is. Let's find what f of x is. If f of x is equal to ax divided by x plus 1, this is going to be equal to ax times 1 over x plus 1. That means f of x would equal to a f of x times 1 over f of x plus 1. This will be equal to a times ax divided by x plus 1 times 1 divided by ax divided by x plus 1 plus 1. This will simplify to a squared x divided by x plus 1 times 1 divided by ax plus 1, ax plus x plus 1 divided by x plus 1. But instead of ax plus x plus 1 divided by x plus 1, we can just simplify this to x plus 1 divided by ax plus x plus 1. X plus 1 multiply x plus 1 here, and we have this is equal to a squared x divided by ax plus x plus 1. But remember, this is f of x. They say what's the value of a that what's the value of a that f of x is equal to x. So let's equate that. We don't need any of this anymore. So basically, we're saying what's the value of a that a squared x divided by ax plus x plus 1 will equal to x. The first thing that you will notice is that if x is equal to 0, this right hand side will equal to the left hand side. So for this to be equal, the first thing, is my Bible? Thank you. For this to be equal, the first thing that you notice is x is equal to 0. So now, if x is equal to 0, no matter the value of a, they will be equal to each other. So we first of all have to specify that x is not equal to 0. Because as I said, if x is equal to 0, even if a is 2, if a is 3, if a is 4, if a is 20, if a is infinity, if a is not, like if a is almost infinity, so no matter the value of a, as long as x is equal to 0, f of x is equal to 0. Now let me just go by it again. Let's say that means f of x is equal to ax divided by x plus 1. If x is equal to 0, that means f of x is equal to 0, right? That means f of x will equal to f of 0, right? And f of 0 here is what? Equal to 0. So you can see when x is equal to 0, you are basically not doing anything. No matter the value of a, it will still be equal. So the first assumption I'm going to make is let x not equal to 0. Now let's continue solving. That means a squared x will be equal to ax squared plus x squared plus x. Remember, you multiply x, cross multiply, you have a squared x is equal to ax squared plus x squared plus x. This will be a squared x will be equal to a plus 1 bracket x squared plus x. Now, since we went to the side that x is not equal to 0, you can divide all through by x. So we have a squared will be equal to a plus 1 times x plus 1. Good. Now we can get two simultaneous equations. The first one is a plus 1 is equal to 0. And how do you get this one? This is because for a squared to be independent, for a to be independent, a should not be equal to a function of x. That means this function here, that x, should be equal to 0. That means a plus 1 times x should be equal to 0. And since x is not equal to 0, then that means you can cancel this out and you have a plus 1 is equal to 0. This is the first simultaneous equation. And this will give you an answer that a is equal to -1. But I'm just going to go further, because what if you got a plus b plus 1 is equal to 0? Then you need to go for the second simultaneous equation that you get, the second system of equation that you get. And that one is a squared is equal to 1. After you have made this equal to 0, you have a second simultaneous equation, a squared is equal to 1. So this will give you that a is equal to plus 1 or minus 1. And this one will give you a is equal to only -1. Which one are you going to pick? You have a is equal to -1, and you have another that says that a is equal to plus 1 or -1. Remember, they are simultaneous equations. So whatever value of a you are picking should satisfy both equations. And a equals to -1 is the only one that satisfies both equations. If after you have solved this one, you get a is equal to +1, and after that is you get a equals +1 only a equals +1, maybe a equals +1 and minus and 2, a equals 1 and 2, and you solve this one, you get a equals -1, then there's no solution. There's no value of a that you use that will give you that equal to each other. But after you have solved, you get a solution of a that satisfies both equations, both the first one and the second one. Then that solution will be the correct answer. So we have a is equal to -1 as the correct answer. I am just going to satisfy the ego that most people have, and I'm going to use a equals to -1 to prove to you people that when a is equal to -1, f of x is equal to x. When a is equal to -1, f of x is equal to -x divided by x plus 1. F of x will equal to -f of x divided by f of x plus 1, which will equal to negative times -x over x plus 1 divided by, or times 1 over -x divided by x plus 1 plus 1. This one changes to x plus 1 divided by x plus 1. -x plus x turns to 0. So you have 1 divided by 1 over x plus 1, which simplifies to what? X plus 1. X plus 1 times x plus 1, you have negative times -x. And this simplifies to plus x. So you can see f of x is equal to x. When you use a is equal to +1, you get an entirely different answer, because that a equals +1 does not satisfy the two system of equation. Only a equals -1 satisfies the two system of equation. And that's how you get the answer. A is equal to -1. And that's option D. Question 25, we have option D. Question 26 now. Question 26 says we should find the integral of sin to the power of 4x. Question 26 says we should find the integral of sin to the power of 4x dx. First of all, okay, so then we should find the coefficient of x in the final simplified expression of I. I want us to do some magic here. Sine cos 2x is equal to 1 minus 2 sine square x. That means 2 sine square x is equal to 1 minus cos 2x. That means sine square x is equal to 1 over 2 minus cos 2x over 2. Right? It's clear. Right. That means sine to the power of 4x will be sine square x all squared, which is equal to 1 over 2 minus cos 2x divided by 2 all squared. Right? Right. If you expand this, you're going to have 1 over 2 times 1 over 2 minus 2 times 1 over 2 times cos 2x over 2 minus 2 times 1 over 2 times cos 2x over 2 plus cos square 2x over 4. This will be 1 over 4 here. This should be negative cos 2x over 2. Good. So sin to the power of 4x is the same thing as 1 over 4 minus cos 2x over 2 plus cos square 2x over 4. So the integral of sin to the power of 4x dx is equal to the integral of 1 over 4 minus the integral of cos 2x over 2 plus the integral of cos square 2x over 4. With respect to x, with respect to x, with respect to x. If you find this integral, you are going to have 1 over 4x. But this is not the final answer. Because remember, you did not simplify this one. So let's wait. Hey, let me write it down. Yeah, I'm coming. Let me write it down here. I think this was the same thing I got last time. But let me cross check. 1 over 2 minus cos 2x over 2 all square. That is 1 over 4 minus 2x, yeah, plus cos square, yes. So now, this cos square 2x can be simplified further. Remember that cos square x is equal to 1 plus cos 2x over 2. Cos square is equal to 1 plus cos 2x over 2. That means cos square 2x is equal to 1 plus cos 4x over 2. That means cos square 2x over 4 is equal to 1 plus cos 4x over 8. This is equal to what? 1 over 8 plus cos 4x over 8. That means sin to the power of 4x is equal to 1 over 4 minus cos 2x over 2 plus 1 over 8 plus cos 4x over 8. 1 over 4 plus 1 over 8 is the same thing as 2 over 8, the same thing as 3 over 8. That means all in all, I hope people can see. This is how I was saying. Okay, I think people can see everything I was writing. That means all in all, sin to the power of 4x is going to be equal to 3 over 8 minus cos 2x over 2 plus cos 4x over 8. Now we can find the integral that we're looking for. And I take the integral of both sides. It will be the integral, continuous integral of everything. So this will be equal to the integral of 3 over 8 with respect to x minus the integral of cos 2x over 2 with respect to x plus the integral of, we don't need any of that. The only thing that we need is this part. Because remember, the question specified that we should find the coefficient of x in the final simplified expression of I. This coefficient of x, this is the term that will give us that. And that is equal to 3 over 8x. The coefficient is 3 over 8. So answer is C, 3 over 8. Question 26 is C, 3 over 8. Question 27 now. Question 27 says that we should find the integral of x divided by x squared minus 4 with respect to x. Wow. Let's solve this. If you find the integral of x squared plus x squared, now actually separate it using partial fraction. But I'm not going to do that. I'm going to follow another method. And that method is u substitution. Let u equals x squared minus 4. Then du will equal to 2x dx. That means du over 2 is equal to x dx. X dx. To apply that limit, that integral, sorry, you have the integral of 1 over u du over 2. So this is equal to 1 over 2 times the natural log of the absolute value of u plus c. This is 1 over 2 times the natural log of x squared minus 4 plus c. Now, this answer is not inside the option exclusively, but you can force it in. Remember that x squared minus 4 is equal to x minus 4 times x minus 2. So this will be equal to 1 over 2 times the natural log of x minus 2 plus 1 over 2 times the natural log of x plus 2 plus c. And this is equal to what? Option D. Question 27. Option D. Now let's solve question 28. And just in case that log is was the natural log of a plus b, a times b. The natural log of ab is equal to the natural log of a plus the natural log of b. Question 28. Question 28 says we should find the limit as x tends to positive infinity of 5x minus 7 divided by 2x squared plus 1. The next thing I want to do is to factorize out x from the numerator and denominator. So this will be equal to x bracket open 5 minus 7 over x divided by x bracket open 2x plus 1 over x. X here will get cancelled out. So this is equal to 5 minus 7 over x divided by 2x plus 1 over x. Now apply that limit. When x tends to infinity, this will be equal to 5 minus 0 divided by 2 times infinity plus 0. This is equal to 5 divided by 2 infinity. This is equal to 0. Anything divided by infinity is 0. So our limit is C, option C, 0. Question 28, C. And how we can solve this is using L'Hospital rule. If we say x is equal to infinity, then this will be infinity divided by infinity. So let's apply L'Hospital rule. Differentiate the numerator, you get 5. Divided by differentiate the numerator, you get 4x. So here you have 5 divided by 4x. You can now apply x equals to infinity, and you have 5 divided by 4 infinity. Anything divided by infinity is 0. If you want to go further, you can differentiate again. If you differentiate this again, you're going to have 0 divided by 4. Now you don't have x again. 0 divided by 4 is equal to 0. So all rows still leads to room. You have 0. Let's go to question 29 now. Question 29. Let f of x equal to x plus 1 over x. If f of x is equal to x plus 1 over x, you should find f inverse of 2. First of all, how do we find the f inverse? Oh, I just got the answer. The f of x to 1. But anyway, let's see if we can solve for it. The f inverse of 2 is let y equals x plus 1 over x, right? Y equals x, y plus x plus 1 over x. That means yx will be equal to x squared plus 1. That means yx minus x squared will be equal to 1. Want to make x a formula? The only way we can do this is using formula. So let's do that. This is yx is equal to x squared plus 1. We have x squared minus yx plus 1 is equal to 0. Now the value for x is equal to negative b. That is negative times negative y, which is positive y, plus minus the square root of b squared, that is y squared, minus 4ac. 4 times 1 times 1 is 4. Divided by 2a, divided by 2. So the x is going to equal to y plus minus square root of y squared minus 4 divided by 2. That means the f inverse of x is equal to x plus minus the square root of x squared minus 4 divided by 2. if f of x equals x plus 1 over x, then f inverse of x is equal to x plus minus square root of x squared minus 4 divided by 2. So we find f inverse of 2. So you plug in 2 into this function, and this will be equal to 2 plus minus the square root of 4 minus 4 divided by 2, which is equal to 2 plus minus the square root of 0 divided by 2, which is equal to 2 divided by 2, which is equal to 1. So answer is equal to 1. Option C. Question 9 is option C. Question 30. We're almost done. Question 30 says, if y is equal to x ln x, we should find the second derivative of y. Before we find the second derivative of y, let's find the first derivative of y. Y prime is equal to, you keep x constant, differentiate ln x, 1 over x, plus you keep ln x constant, differentiate x, that's 1, so that'll just be 1 plus ln x. So y prime is equal to 1 plus ln x. Find the second derivative. This will be equal to 0 plus 1 over x. So your second derivative is equal to 1 over x. And 1 over x is option D. Question 30. D. Now, I just want to just point out there that there's actually an method to solve this question. I always want me to, as I said, as long as you're doing the correct thing, you will end up getting the correct answer. So the second method you can use to solve the question is, let's use logarithm. Let's find the natural log of both sides again. The natural log of y is going to equal to the natural log of x ln x, which is equal to the natural log of x plus the natural log of natural log of x. So ln y is equal to ln x plus ln x. If you differentiate both sides, we are going to have 1 over y dy over dx, 1 over y times y prime is equal to 1 over x plus 1 over ln x times 1 over x. 1 over ln x because you are differentiating this whole ln x times, you are differentiating this whole ln x ln x. And since ln x is not function, you're going to do 1 over ln x, which is the inner function. Then differentiate the inner function, which is ln x. You differentiate the inner function ln x, you're going to have 1 over x. So answer is going to be 1 over x plus 1 over ln x times 1 over x. Now, you multiply both sides by y. Now, y prime is equal to y times 1 over x plus 1 over x ln x. Now, what is the value for y? Y is equal to x ln x. So you have x ln x times 1 over x plus 1 over x ln x. If you multiply all, you're going to have y prime is equal to x plus 1, which is the same answer we got last time. So all you need to do is differentiate it again, and you have y prime is equal to 1 over x. Because as math, everything flows. There's no one fixed solution to the question. You can solve it in multiple questions. As long as you're doing the right thing, you get the right answer. So this question is done. Option, I think I've written an option already. Question 30. Yeah, I've written an option. Let's go to question 31. Question 31 now. So we find the derivative of f of x is equal to 4x to the power of 5 minus 3x squared plus 8. Find the derivative, that will differentiate both sides. That will be 20x to the power of 4 minus 6x. And this corresponds to option D. Question 32. I don't want to put out there that option A says 20x power 4 minus 6x plus c. That is wrong. There's no supposed to be plus c. Just 20x power 4 plus minus 6x. There's no supposed to be plus c. That plus c there is a distraction. Ignore it. Question 32 says, at which of the following intervals is the function f of x equals x plus 2 divided by x minus 1 and x minus 4 continuous? So we have f of x is equals x plus 2 divided by x minus 1 times x minus 4. When is this continuous? Basically, what the asking us to find is the domain. And for the domain, we need to make sure that x minus 1 times x minus 4 is not equal to 0. This is what we're looking for when x minus 1 and x minus 4 is not equal to 0. So when it's equal to 0, when x minus 1 times x minus 4 is equal to 0, this is only when x is equal to 1 or when x is equal to 4. That means we want all the numbers except for 1 and 4. How do you do that? Well, simple. From negative infinity to 1 is not included. Union from 1 to 4, 1 and 4 is not included. Union from 4 to positive infinity, 4 is not included. So you can say I added all the numbers from negative infinity to infinity, but I have removed 1 and 4. So this here is our range that is continuous at basically our domain. And that corresponds to option C. Negative infinity, no, not option C, corresponds to option B. Negative infinity to 1, 1 to 4, 4 to positive infinity. Option B. It's 2. B. Let's go to question 33 now. Question 33 says evaluate an integral. I think that sounds easy. Question 33. We should evaluate the integral of 3x plus 1 to the power of 4 with some disrespect to x. Let u equal to 3x plus 1, then du is equal to 3x. Sorry, 3 dx. That means du divided by 3 is equal to dx. We're going to use this to apply our u substitution. So we have the integral of u to the power of 4 du divided by 3, which is equal to 1 over 3 times the integral of u to the power of 4 du, which is equal to 1 over 3 times u to the power of 5 divided by 5 plus c, which is equal to u to the power of 5 divided by 15 plus c. U to the power of 5 is the same thing as 3x plus 1 to the power of 5. And this is our answer, 3x plus 1 to the power of 5 divided by 15 plus c. And that is option C. 3x plus 1 to the power of 5 divided by 15 plus c, option C. So we have question 33, option C. 34 now. Question 34 says, determine the volume of a solid obtained by rotating the region bounded by. When you're finding the volume, please remember I said when you're finding the area bounded by two curves. I told you that you don't what am I stammering? You don't need to care about the axis there. You don't need to care the x axis or the y axis. But when it is volume, you need to care about the axis. So here this is determine the volume of a solid obtained by rotating the region bounded by y cube and x equals to 4y. In the first quadrant, abound the y axis. In this particular question, they gave us easier axis to use. So you can just solve it normally. So you have the volume bounded by x is equal to y cube and x is equal to 4y. Abounds the y axis. So we're looking for when x is equal to y cube equal to x is equal to 4y. So when y cube is equal to 4y, basically when y squared is equal to 4, that's when y is equal to, oh my god, why can I be equal to 0? So wait, when you have, so first of all, y can be equal to 0. So you have y cube minus 4y is equal to 0. So you have y times y squared minus 4 is equal to 0. So you have y times y minus 2 is equal to 0. So the point is that y correspond to each other. You have y is equal to 0, you have y is equal to -2, and you have y is equal to +2. So these are your 3 points of y. But remember, they say something. They say in your first quadrant, and that first quadrant is where y is positive and x is positive. Only when y is positive and x is positive. So the 2 points they are taking is 0 and +2. Only 0 and +2. So here we have integral from 0 to +2 of pi f of x squared with respect to x. So in this way, they say around the y-axis, so that is f of y squared with respect to y. This part is a constant, so you can bring it out as pi here. So you have f of y squared. Now what's f of y? They say f of y is equal to y cubed and 4y. So we have y cubed all squared minus 4y all squared with respect to y. So this is equal to pi times the integral of y to the power of 6 dy minus the integral of 16y squared dy from 0 to 2, from 0 to 2. This goes equal to pi times y to the power of 7 over 7 minus 16y cubed over 3 from 0 to 2. When y is equal to 0, everything will be equal to 0, so you can ignore the lower limit. The way that we need to find is the upper limit. And the upper limit when y is equal to 2, this will be equal to pi times 2 to the power of 7. 2 to the power of 7. 2 to the power of 6 is 32. No, 2 is 64. 2 to the power of 7 is 128. This is 128 divided by 7 minus 16 times 2 to the power of 3. 2 to the power of 3 is 8. 8 times 16 is 64, 128. So this is 128 again. 128 divided by 3. So what we have here is this is equal to 128 pi times 1 over 7 minus 1 over 3. 1 over 7 minus 1 over 3 is the same thing as 3 over 21 minus 7 over 3. And this is equal to 128 pi times -4 over 21. The negative, since it's absolute, but the negative changes to positive. So we have this is equal to 128 times 4 is 512. So we have 512 pi divided by 21. And that corresponds to option 512 pi divided by 21. That corresponds to cubic units. That corresponds to option D. Question 33. We have option D. Yeah? Question 34, sorry. Many question 35 now. Final question. And possibly the simplest question. Question 35. If or let f of x, or defining f of x as x squared plus 3x plus 10, make it minus 10, divided by x minus 2, when x is not equal to 2, and it's equal to k when x is equal to 2. We should let f of x be continuous at x equals to 2. Then what's the value of k? So for something to be continuous, then the left hand limit must be equal to its right hand limit. So when x is equal to 2, the left hand limit would be this function. The right hand limit would be this same function. So basically, we're just finding the limit. Normally, the way you see this function is normally x is greater than 2 and x is less than 2. So we are finding the limit at that point where x is equal to 2. you first of all find the upper limit, the left hand limit, and then the right hand limit. But since in this case, the left hand limit and the right hand limit is the same function, that's when x is greater than 2 is this function, when x is less than 2 is this function. But when x is exactly equal to this one is equal to k. So this function we're going to use left and right. So we always want to make sure that the limit of x squared plus 3x minus 10 divided by x minus 2 as x tends towards 2 is equal to k. Good. Now when you put in x equals to 2, you notice that here you are dividing by 0 and you don't want to divide by 0. So what you do, you factorize x squared plus 3x minus 2 minus 10 is the same thing as x squared plus 2x plus x minus 10. No, x squared plus 5x. Let me use 5x. Then x squared plus 5x minus 2x minus 10. This is x times x plus 5 minus 2 times x plus 5. This is x minus 2 times x plus 5. But remember, you are dividing by x minus 2. So this will be divided by x minus 2. This will cancel out this, and you have x plus 5. So now you can apply your limit. By the time you put in your limit, you have 2 plus 5. That means k is equal to 7. But in case you want to use this method, you can use L'Hospital rule. Differentiate the numerator, you have 2x plus 3 divided by 1. Plug in x equals to 2, you have 4 plus 3, and you have the same thing, k is equal to 7. So that's the answer, k is equal to 7, option D. And that brings us to the end of this test review. I will show you the solutions that I've done so far in case you want to go through the answers that were picked. I think I've already solved this before. I'm supposed to have like a piece of paper that has the marking guide. So we have question option 1 C D E B A C D B E A C D E B A C D E B A B E C B B B E C B B D E B B C D E B B C D D B C B D D B C B B E E D D B E D D C D C D C D C C D and D B C D D D B C D D. Yep. So this is the marking like that. We confirm. I'm just gonna meet them question 11 and question 25 are not the same as the one in the marking guide. The rest is not correct. Then may I fail question 2, question 21, and question 25. I failed question 25. I was not still defending the correct answer as question 25. But yeah, me, I don't even know how to solve question 25 entirely. So I picked none of the above. But when I saw the answer was actually wrong, I was still defending them so that whoever picked the correct answer will get their mark. Because the reason why I argue with lecturers is not for me to get my own full mark, so that the people that actually solve can, get their solutions what get the end of their solution. Yeah, so this is the end of this video. I beg. I'm tired. I'm gonna do other things. Thanks for watching. Thanks for tuning in. And see you in the next video. Bye. There should be like some outro whenever I'm closing this video. Like some outro. Let me see if I have any outro. So watch and be pleased. Yes.